Good afternoon. Good afternoon. What I'm going to do today, this video, is about synoptic weather map. It's about synoptic weather map. Synoptic weather map. So what I'm going to do, I'm going to show you what a synoptic weather map looks like in winter and also in summer. That's what I want to show you. So let's start with summer first. Let's start with summer. Summer season. How can you identify the summer season on a synoptic weather map? So I'm just concentrating mainly on the synoptic weather map. That is the information that I want to use. Okay. So the first thing is the date. If you can look at this synoptic weather map, can you check the date? It's telling you that this is 16 October 2025. Okay. So the first thing that you check is the date. The date. Okay. I think in this instance, we have got 16 October 2025. 16 October 2025. So we have qualified that. Then the second thing that we check is the low pressure in the interior. Can you check the low pressure in the interior here? The low pressure that is in the interior. So we have got low pressure, inland, or low pressure inland or in the interior or continent. That is inside there. Okay, that is number 2. That's another way of determining whether it's summer. So we have used the date. You can see the date that we have is 16 October 2025. The second thing is our low pressure in the interior. You can see the low pressure that is in the interior. Number 3, you can look at the position of high pressure systems. I'm talking about the South Atlantic High, and South Indian High. In what position do you find these two high pressure systems? They move further south. Remember, they move further south because of the movement of the ITCZ. The ITCZ is now in the southern hemisphere. So our South Atlantic High and South Indian High, they move further south. This is what shows you that it is indeed summer. That's another thing that you can look at. I'm talking about this high pressure system. You can see this is our South Atlantic High. This is our South Indian High. So when they move further south, which means they are now reaching, you can see also the position of your cold front as well. The position of your cold front, that's another thing that we also look at. Position of your cold front. Position of the cold front. You can see it's south, further south as well. It's further south, the position of your cold front. If you can check here, you can see your cold front is further south. Of course, you can even say the mid-latitude, of course, it's further south because it's reaching here because of the high pressure. They've got a blocking effect. This is summer. So that's why you see them. They are not close to Cape Town. They are far away from Cape Town. They are further south. You know how they move from west to east? So they are further south. Why? Because of the shifting of the ITCZ that has actually changed the position of the two high pressure systems. That is your South Atlantic High and your South Indian High. So that's why you see them. They are not close to Cape Town. So we have said we looked at the date It shows you that it's summer. That is 16 October 2025. That's number one. Number two, we look at there is low pressure in the interior, low pressure inland or in the interior or continent. This is the low pressure that we have. This low pressure, we also call it the thermal low. We call it the what? The thermal low. We call it thermal low. So that at least if you are asked, okay, it's called the thermal low. We call it the thermal low. Okay, so that's what we got in the interior. So this is what we get. We use the date. There is the date, the low pressure inland in the interior position of our high pressure system, that is both the South Atlantic High and the South Indian High. They move further south because of the movement of the ITCZ. So in summer, our ITCZ, which is our intertropical convergence zone, is in the southern hemisphere. So this is what causes the high pressure system, that is the South Atlantic High and the Southern Indian High, to move further south so that they have a blocking effect. That's why you see even the cold front or in general the mid latitude, you can see that it's further south. It's not close to Cape Town. That's why the weather of Cape Town in summer is not affected by the cold front. Why? Because of the position of the South Atlantic High and also position of your South Indian High. They've moved further south, and our ITCZ have moved south of the equator, which means now inland what we have got low pressure. That's what is happening there. We have got low pressure inland. We have got low pressure. So I've used this. Let's also use this one. You can also see here, I'm not going to talk about about what the question is all about, but I just want to show you what I'm talking about. So here you can see, just to qualify that it's summer, number one, can you see the low pressure inland? This is the low pressure. So the other thing that you can also look at, number 5, to show that it is summer, it is the weather conditions. Weather conditions inland. Okay, you can see we have got unstable weather conditions. This is summer because of the L that yes. We have got unstable weather conditions. How do we see that we have got unstable weather condition? Can you see? Overcast, cloud cover, it's overcast. It's overcast. You can see in terms of wind speed as well. You can see the way it is of overcast. We are likely to have thunderstorms. We are likely to have thunderstorms as well. But on the eastern side of the moisture front, on the eastern side of the moisture front. So inland, you can see in terms of cloud cover, you can see with the weather conditions that are there, we have got an overcast, thunderstorms on the eastern side of the moisture front. I think more of the Great Gulf will understand this concept of moisture front. So in general, we are saying that we are likely to have unstable weather conditions. That's basically what we are talking about. We are likely to have unstable weather conditions, which means the cloud cover is overcast. We have got higher temperatures as well. You took in terms of temperatures, higher temperatures as well. That's something that you can see. Okay, that is what we have deduced from this. You can see this is a typical summer. Of course, this is more of your moisture front. Okay, this is inland. Of course, you can also see with the position of your high pressure system. This is your South Atlantic High. This is your South Indian High. They have moved further south. Like what I've said here, that the position of the high pressure system, South Atlantic High and South Indian High, move further south because of the movement of the ITCZ, which is our zone of low pressure. That is our intertropical convergence zone. So now it's south of the equator. That's why the South Atlantic High and the South Indian High have also moved further south. Let's check if we can get another question paper that I've got this as well. You can see what is happening here. This is the same thing. We have got our low pressure. This is typical summer. We have got our low pressure in the interior. Check in terms of temperature. Check in terms of temperature. Okay, our air temperature, you can see that is very high. So this is in typical summer as well. You can see the cloud cover is overcast. You can also see the position of your high pressure system. They've moved further south. Of course, this is an area of constant pressure that separates two high pressure. This is a saddle at B. But here we are saying now our South Atlantic High and our South Indian High have also moved further south, which shows that it is summer. And the low pressure that we have inland or or in the continent or in the interior, it also tells you that it's summer because our intertropical convergence zone have moved further south. So this also something that supports what we have also written as the typical conditions for summer. Okay, let's check another paper. You can also see from here what is happening. Look at here, we have got in terms of the cloud conditions, the weather conditions that are in the interior. Besides having the low pressure in the interior, look at the weather conditions. They also tell you that it's what? It's summer. Look at the position of your two high pressure system, South Atlantic high and South Indian high. You can see that also it's a typical summer. Look at the region, the elongation of the isobars of the South Indian high towards the low pressure in the interior. It also tells you that it is what? Indeed summer. So this is how you can actually see that it is summer. Look at the position of your cold front. It's further away from Cape Town. Why? Because of the presence of these two high pressure systems that has got a blocking effect. You understand? That is a blocking effect. They've moved further south, which means the cold front cannot affect the weather here in Cape Town as it does in winter. So the same thing that we have talked about. We have talked about the date. I think I showed you the date in this question paper. This is the date. That's what I said. It's summer, 16 October 2025. Number 2, we talked about the low pressure inland or in the interior. This is the low pressure that we are talking about, the low pressure that is in the interior. If you can see an L inland or in the continent, it tells you that it is what? It is summer. If you can see L inland, it tells you that it is a typical summer. It is a typical summer. It tells you that it is a typical summer. If you can see this L inland, it tells you that it is what? Typical summer. Okay, I'm just supporting. Okay, this is the low pressure that you can see inland. It tells you that it is typical summer. What else do we have? Okay. It tells you that it is typical summer. So these are the different, these are the different question papers, but they're showing the same climatic conditions. So we have actually seen how you can determine it's summer by looking at the date. We have also used the low pressure. Let's check here now the position of the high pressure system, South Atlantic and South Indian high. They move further south because of the movement of the ITCZ. You can see the position of our high pressure, South Atlantic high, South Indian high. They have moved further south. Why? Because our ITCZ is now south of the equator. That's why we have got low pressure in the interior. So you can see the position, they've shifted the position. Okay, and you can also see that it's ridging. There is an elongation of isobars of the South Indian towards the low pressure in the interior. So this is what tells you that it is indeed summer. This is what tells you that it is indeed summer. So I'll use that one. Then number 4, the position of the cold front is further south. If you can see your cold front here, it's far away from Cape Town. It's further south. Why? Because of the blocking effect of our high pressure, South Atlantic high and also our South Indian high. You can see also in terms of its movement, it does not affect now the weather during summer. That's basically what we are talking about. It does not affect. Why? Because of the blocking effect of our South Atlantic and also our South Indian high, because they have moved further south because of the changing position of our intertropical convergence zone. And remember, in this time, our Kalahari high is not that active. There isn't too much subsidence in the interior. So this is also showing you that it is typical summer. So that is it. The weather conditions as well. You can see with the weather conditions here, it's cloudy, the temperatures. We are likely also to have thunderstorms, the strong winds. How are we seeing it? We are seeing by this weather station model on the eastern side of our moisture front. So that all tells you that it is indeed what? It is summer. Okay, the weather conditions. Okay, these are the things that I've listed there. Same applies. I can show you on this one, that is B. You can see there's low pressure in the interior. Position of your two high pressure system, you can see that they are further south. Why? Because in the interior there isn't any subsidence. Our Kalahari is very weak. That's why we have got the low pressure and we have got the position of our high pressure system changed. They've moved further south. This is a typical summer as well. Okay.